students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12, and this is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. So now let us come back to our today's session. Our today's session is on the chapter Arithmetic and Geometric Sequences and Series, and our today's topic is the arithmetic sequence or the arithmetic progression. They mean the same. Okay? Now, I am seeing that this is the arithmetic sequence. What is meant by this word sequence? You may have a sequence of numbers, you can have a sequence of letters, you may have a sequence of words. But since this is a math video, we will be interested in having sequence of numbers. And what is the meaning of a sequence of numbers? It is a set of numbers which follow a particular rule. Okay, let me take one sequence of numbers 1, 4, 9, 16, dot. And what does this 3 dots mean? What do they mean? These 3 dots mean that this is an infinite sequence. This sequence will be just continuing. You will never be having the last term, a last term for this sequence. It will never stop. Okay? So, this is an example of an infinite sequence. For an infinite sequence, you do have the first term, but you do not have the last term. Okay? The last term is missing because it just continues forever. Whereas if you take these 4 terms, this is also a sequence, but it is a case of a finite sequence because it is having both the first and the last terms. Okay? So for a finite sequence, you have the last term. Whereas for an infinite sequence, there is no last term. As I'm saying that this is a sequence of numbers. Therefore, it should be having some rule. What is the rule for this sequence? Obviously, we are seeing that these are all squared numbers. So, they are all squares of natural numbers. Therefore, this is 1 square, this is 2 square, this is 3 square, this is 4 square. The next term should be equal to 25, which will be 5 square. Therefore, this is the rule. Only squared numbers can be included in this infinite sequence if we take the infinite sequence. And if we take the finite sequence, it is containing only 4 terms. We cannot insert anything in between. Okay? So, now, is this an arithmetic sequence? No, it is not an arithmetic sequence. It is a sequence of numbers, no doubt, but it is not an arithmetic sequence. So, which sequences are termed as arithmetic sequences? Let's see. An arithmetic sequence is a sequence in which each term differs from the previous term by a fixed number. Okay, so let me take another example of a sequence. 2, 4, 6, 8, dot, another infinite sequence. And they are saying an arithmetic sequence is a sequence in which each term differs from the previous term by a same fixed number. Okay, so if I take the second term, it is differing from the first term by the number 2. 4 minus 2 is equal to 2. So if I take the difference between the second and the third terms, 6 minus 4 is equal to 2 and 8 minus 6 is also equal to 2. So there is the same fixed number by which the next term is different from the previous term. Okay? And this common number is known as the common difference D. So in this sequence, the common difference D is equal to 2. And it is an arithmetic sequence because we are having the common difference. Okay? This common difference, when added to a term of the sequence, generates the next term of the sequence. Definitely. Because if I add this common difference of 2 to the first term, that is 2, I get the second term, 4. 4 plus 2 is equal to 6. 6 plus 2 is equal to 8. And if I add 2 to 8, I'll be getting 10, which will be our fifth term of the common difference. Sorry, of this arithmetic sequence, right? So this is an example of an arithmetic sequence with a common difference of 2. A sequence is arithmetic if and only if un minus 1 minus un is equal to t. Now what is the meaning of un plus 1? Sorry, it is un plus 1 minus un. So what is the meaning of un plus 1 or un? Un plus 1 is the n plus 1th term. And what is n first of all? N is the term number. 2 is the first term or term 1. Therefore, the value of n is equal to 1 and the value of the first term is equal to 2. So, n is equal to 1 in this case and u1, because n is equal to 1, we say u1 or the first term is having a value of 2. For the second term, it is term number 2. So, n is equal to 2 and the value of the second term or u2 is equal to 4. This is the third term, so n is equal to 3 and u3 is equal to 6. Okay, now you understand the difference between un and n. Okay, so un, that plus 1, that is the next term, minus un, that is the previous term, is equal to the common difference d. Where n belongs to the set of natural numbers, obviously n is starting with the value 1, the first term. So n belongs to the set of natural numbers, or you may say that n belongs to the set of positive integers. And d belongs to the set of real numbers. D can be a positive number, d can be a negative number, d can be a rational number, d can be an irrational number. D belongs to the set of real numbers. Okay? And d is not equal to 0. I have included this condition. Let me show you the reason. Okay, so let me write over here. If 5 is the first term of any arithmetic sequence whose common difference is equal to 0, I add 0 to 5 to get the second term of the sequence. 5 plus 0 is equal to 5. And if I add the common difference 0 to the second term, I should be getting the third term. So 5 plus 0 is again a 5. Therefore, I am seeing that if the common difference is equal to 0, I get a sequence of identical terms. I do not get new terms. Hence, I have included this condition. D is not equal to 0. Okay. Now, the last thing that we have to know about arithmetic sequences before starting with our questions. The general term formula is, obviously for an arithmetic sequence, is un is equal to u1 plus n minus 1 times d. Okay. So, how are we deriving this formula? How are we getting this formula? Let's see. Let's take this very arithmetic sequence. Okay. So, u1, the first term, is equal to 2. I can write 2 plus 0 times d. I can write 2 in form of 2 plus 0 times d because I have to bring it in this format. Okay. So I am writing u1 equal to 2 plus 0 times d. Or this can be written as 2 plus 1 minus 1 times d. 1 minus 1 is equal to 0. What is the value of u2? u2 is equal to 4. So we start from u1. We always start from u1 because the formula is saying that we always start from u1. So we are just verifying whether the formula is correct. So the first term, we write the first term plus, it is 2 plus 2. And 2 is the common difference. So I can write this as 2 minus 1 times d. I'm writing d because I want to relate this to this part. So it is 2 minus 1 times d. Or I can write this as u1 plus 2 minus 1 times d, where 2 is equal to n. Okay, where n is equal to 2, this is equal to 2. When n is equal to 1, this is equal to 1. Minus 1 part is common. What happens to u3? u3 is equal to, I'll be taking u1, so it is 2 plus, let me see, I'm seeing that n minus 1. So let's check. N is equal to 3, so 3 minus 1 times d, where d is equal to 2. So that should be equal to 2 plus 2 times 2. That is 2 plus 4, which is equal to 6. So we are getting the correct formula. So it is 3 minus 1 times d. Okay. Therefore, obviously we may write in place of 3, if I take the subscript as n, it is the nth term or un, which is equal to u1 plus n minus 1 times d. So we have verified this formula. Okay. So if you are asked to find the sixth term of this sequence, arithmetic sequence, we will be writing u6 equal to u1 is equal to 2 plus 6 minus 1. N is equal to 6. So 6 minus 1 is equal to 5 and the d value is equal to 2. So 5 times 2 is 10 plus 2 is equal to 12. So the sixth term should be equal to 12, and of course the sixth term should be equal to 12. If you add 2 to 10, you will be getting 12. So sixth term is equal to 12. Okay. That is what is given by this formula. Okay. So now let us start answering the questions related to arithmetic sequences. The first question of this topic, consider the sequence. Now they have not said that it is an arithmetic sequence. It is a sequence, so it follows some rule, but they have not mentioned the word arithmetic. So you cannot just assume the sequence to be an arithmetic sequence. 6, 17, 28, 39, 50, implying that this is an infinite sequence. And the first subpart says, is 325 a member of the sequence? Okay, so let's start answering. Subpart E. 325 a member, we do not know. But let us first of all check what type of a sequence is this. We are seeing 17 minus 6 is equal to 11. 28 minus 17 is equal to 11. 39 minus 28 is equal to 11. And of course 50 minus 39 is also equal to 11. Therefore, there exists a common difference between the numbers. Hence, it is an arithmetic sequence. You have to show this first. That there exists a common difference. You write that 17 minus 6 is equal to 11. 28 minus 17 is equal to 11. 39 minus 28 is equal to 11. So, therefore, there is a common difference. and the common difference D is equal to 11 in this case. Okay. So now we have to find whether 325 is a member of the sequence or not. We know the formula for the nth term. We will be using that. Un is equal to u1 plus n minus 1 times t, where we know the value of u1, that is 6, and the value of d is equal to 11. So in place of un, we write 325. 325 is equal to 6 plus, we do not know the value of n. We have to find that, which term is it, and whether it is a term of the sequence or not. Okay. If n is having a fractional value or a negative value, then straight away we will be saying that it is not a member of the sequence, because we know that n can have only positive integer values or natural number values. Okay. So 6 plus n minus 1 times 11. And if I just open this parenthesis, I get 6 plus 11n minus 11, which is equal to 11n minus 5. And rearranging a bit, I write it in this form. 11n minus 5 is equal to 325, and if we add plus 5 to both the sides, we have 11n is equal to 330, which gives us the n value as 330 divided by 11, or n is equal to 30, which is a natural number or a positive integer. Hence, 325 is a member of the sequence. Yes, it is a member of the sequence. It is the 30th term. So we are done with the subpart A, coming to the subpart B. Okay, I start from here. Which term of the sequence is 1097? Again, we will be taking the same formula, and I'll be writing 1097 in place of un. So 1097 is equal to u1 is equal to 6 plus n minus 1 times 11. Because since this is the same series, obviously the common difference and the first term, they will be the same. So, and this part we have simplified. This is equal to 11n minus 5. Okay. So 1097 is equal to 11n minus 5. And if I add plus 5 to both the sides, I get 11n is equal to 1102, because 1097 plus 5 will be giving us a sum of 1102. And what is the n value? 1102 divided by 11. 1102 is not divisible by 11. 1100 is divisible by 11, definitely. So, what can I write? It is 100, 1100 and 2 over 11. Because we are having a remainder of 2. Therefore, we see that n is having a fractional value, which is not possible, indicating that 1097 is not a term of the sequence. Okay? And which term of the sequence? See the format of the question. Which term of the sequence is 1097? You will be prompted to find somehow an integer value, a positive integer value of n, to write the answer as this is the term. This has been given just to puzzle you, to confuse you. 1097 is not a term of this sequence. So you write 1097 is not a term of the sequence. Okay. So students, we have solved the first question on this topic, arithmetic sequences. Let us stop over here for today. We'll meet again tomorrow in our next video session on the same topic, arithmetic sequences. Thank you for watching this video till the end. Please give this video a like in case you found it useful. Please subscribe to my YouTube channel and do not forget to press the bell icon so that you get notified as soon as I publish a new video. So, see you tomorrow. Till then, bye.